Okay, so we're considering these two functions. One is f of x equals 8x minus 2x squared. One is 3x minus 5. So this is a quadratic. It's squared, so it'll be a parabola. This is a line. And I'd like to do a couple of things. I'd like to sketch the functions. I would like to sketch their derivatives. And I would also like to determine formulas. I'd like expressions that describe those derivatives. So let's do one thing at a time. All right. So in graphing a parabola, this is kind of nice and easy to graph, specifically because I can factor it very easily. Right? I can find out what the zeros of that parabola are. Right? If I set the equation equal to 0, I'm going to find that x is 0 and x is 4. And that's going to give me a couple of points on my graph. So I know that the graph is going to be 0 here and 0 here. Because it's a parabola, I know that its vertex is halfway in between. It's symmetric. So it's the same here as it is here, so it's symmetric. Because this is a -2, I know that it will be a frowny face. And if I plug 2 in, which is the halfway between of 0 and 4, I get 8. So we get something that looks like this. I can plug 2 in here, I get 4 times 2, which is 8. So that's how I know how tall to go. And I know that that's the highest point because the highest point is always halfway in between the zeros. There are a bunch of other algebra ways that you can determine the graph of a parabola. I'm not super invested in us knowing all of those this semester. We are going to come up with cooler calculus ways of graphing things that are super powerful beyond parabolas. They'll do second-degree polynomials, third-degree polynomials, fourth-degree polynomials. And so the derivative is going to do a lot of work for us in the future. So graphing these, I don't want to give you anything too rough. Okay, so here's y equals f of x. That's what it should look like. So what did f prime of x look like for us? Where is it 0? Where, if anywhere? It could always be positive. Where, if anywhere, is the derivative 0?
X equals 2.
At 2, right? There's this point up here where it's flat. The tangent line is flat. So it's here. What about to the left of this point? Is the derivative up here or is it down here? So is the derivative positive over here or negative over here?
Positive.
Positive y.
Closer to 0 is the steeper the tangent, the steeper the slope.
Well, it kind of levels off here, right? So closer to 0, oh yeah, closer to 0 here, the steeper the slope is. Yeah, that's exactly right. I've got big positive slopes over here at 0. So I should be big and getting down to 0. And what about over here? Is it positive or negative? Or just 0? I'm expecting the graph of the derivative to be down here or up here. All right, so negative y. Yeah, because the function is decreasing, I'm going to have negative slopes. So I'm expecting negative slopes over there. And they're going to be getting steeper, right? This is a big negative number. It's going to correspond to a steep tangent line. Right? So a steep tangent line corresponds to a larger negative number. And kind of shallow tangent lines, like are here, right, are going to be small negative numbers. So we've got something roughly that looks like this. What I don't know just from looking at F, though, is does F prime have a little bit of bow to it? Is it curvy or is it straight? Okay. So I'm interested in finding out exactly what that derivative is. And right now, today, f prime of x is strictly defined to be this limit, right? The limit as h approaches 0 of f of x plus h minus f of x, all divided by h. So, fun times, right? Now a bunch of algebra that nobody wants to do. All right, I'm gonna have a limit f of x plus h. That's 8 times x plus h minus 2 times x plus h, the quantity squared. Right? I just plug an x plus h in everywhere where I had an x in f. Right? It's 8x, so f of x plus h will be 8 quantity x plus h minus 2x, so I'm going to have an x plus h squared. I see that here. So there's f of x plus h as a quantity. And then I'm going to subtract f of x. I know exactly what f of x is. The problem told me to begin with, 8x minus 2x squared. I'm subtracting all of it, so I'm going to put it in parentheses here. And then I'm going to divide by h. That's easy. Now that is a big mess in the numerator. But I'm hoping that as I FOIL everything out, distribute all of my constants, as I try to simplify that expression, I'm hoping that it gets simpler. Let's see if that happens or not. And I can distribute that 8. So that's 8x plus 8h minus 2. X plus h squared, I have to do exponents first, right? So that's x squared plus 2xh plus h squared. And then minus 8x plus 2x squared. If there is one place in this problem that I would bet would be the biggest hiccup for everyone, it's right here, right? Because I'm subtracting this entire expression, right? It's minus f of x, and f of x is a lot of stuff from previous in the problem, right? F of x is 8x minus 2x squared. So I have to subtract that entire expression. So it will be important that this is in parentheses so that this minus distributes through each of the terms. So I'm going to get negative 8x plus 2x squared all over h. And we can ignore everything previously now. Now I don't have any more exponents on top of parenthetical types of things. So I'm going to distribute that 2. I'm going to distribute this negative 2, so the negative will carry through with it. So that's a lot of things, right? 8x plus 8h minus 2x squared minus 4xh minus 2h squared. And then minus 8x plus 2x squared. And I see a couple of things that I like immediately. I really like that I'm adding 8x and that I'm subtracting 8x. And I really like that I'm subtracting 2x squared and adding 2x squared. Okay. I especially like that because none of those have h's in them, and I'm hoping to be able to cancel that h in the denominator out, which means that I need an h in everything in the numerator. So I really don't want anything without an h to be left, and there won't be. 8x minus 8x minus 2x squared plus 2x squared. So we'll have 8h minus 4xh minus 2h squared, all divided by h. So that's this expression. It's already looking better, right? Instead of having like 7 terms, I'm down to 3. And all of them have h's in them, which means that I can pull an h out. I could also pull a 2 out if I really wanted to, but there's no real reason to do that. I'm screwing up with the light, sorry. Because I'm really after this denominator h. All right, and back into focus. Okay, so we have an expression like this, right? Pull an h out, and what's left inside, if I factor an h out from the 8h, I'll have an 8, and then minus 4x, minus 2h, and lucky me, h divided by h is 1, because h is not 0, h is just around 0, so I don't have a 0 over 0 situation. And now if h is 0, right, as h is tending towards 0, this 2h that I see here is going to go to 0. It'll be negative 2 times 0. So this is going to go to 0. There it is, going to 0. And I'll be left with 8 minus 4x. So there's my f prime of x. F prime of x is 8 minus 4x. So let's go back up to our graph. Does this look like the graph of 8 minus 4x? I think so. Yes.
Big thing, like you said in the first take, big thing's not calculus, it's the algebra. When I get to the point of plugging the numbers into the formula on that first algebraic line with the brackets, can you just run through that first step again just to see the notation there?
Yeah.
Just because one little error is going to change the whole thing.
So here, this is my general framework, right? This is just the definition of the derivative. So what I'm going to try to do is get rid of this f notation and put algebra in. And so this f of x plus h, I'm going to have to go back up to f of x. So here's f of x. And I'm going to figure out what f of x plus h is. So that's why I have the brackets, these square brackets. Inside of these square brackets is exactly f of x plus h. All I did was I took f of x and I plugged in x plus h everywhere where there was an x. That's what f of x plus h is. So it's going to be 8 x plus h now. So 8 x plus h. Minus 2x squared, not x squared anymore because I have f of x plus h. So it'll be x plus h squared. So that's what's inside of the square brackets. The square brackets are f of x plus h. That's this first term in my difference quotient. And then I'm subtracting f of x. I'm subtracting the entire expression of f of x. And so that's what's inside of the parentheses here. Right? This is exactly f of x, and I'm subtracting all of it. That's, again, from before. And then the bottom is h, and the bottom is h. So that gives me this kind of like algebraic structure that I'm going to try to simplify in future steps. I think that it can help to just think about it in pieces, right? This is a template that I'm working off of. F of x plus h goes in here. So I'm going to find f of x plus h and then just drop it in. And f of x plus h might be complicated. That's kind of why I have this framework. Right? The template is an easy way to look at it. Whereas f of x plus h might be some kind of like huge 10-headed monstrosity. Right? The difference quotient kind of has this nice simple structure that's going to work for everything. I'm just thinking about, all right, what do I paint when it says 1? What do I paint when it says 2? And I can think about it a little bit more methodically. Just go through and plug in what I need. It's easy to get overwhelmed if you think that you should be inferring all of this over here from this, right? Because this seems big and crazy, whereas this didn't look like it was going to be so bad to begin with. Okay? But just going to take it one bit at a time, and it might wind up looking a little messy for a minute, but everything's simplified down really nicely. And writers of math textbooks tend to do that.